Are you a new JavaScript developer looking to learn debugging techniques? Then this video is for you. Or if you have some experience but want to level up your debugging skills, then you may find some information here as well. Hey, this is Veera here, and welcome to a new video in the web development series. In this video, I will be sharing some of the tips and tricks to improve your JavaScript debugging experience. Let's get started. I will be using the code snippets for the demo. Please open the developer tools and then go to the sources tab. Okay. There you will find the snippet section. Snippets are little pieces of JavaScript that you can directly execute from the developer console. You do not need any server or you do not need any setup. You can just write code and run it. For our need, let's create a simple playground script. Function playground. So I'll be using this JavaScript file for all of our debugging demos. So once you have your JavaScript code ready, you can just press Control Enter. That will immediately execute this function. For example, if I write console.log test. Okay, so I need to call the function. Yes. So with this setup, let's move on to the first debugging technique. The first technique that I want to talk about is using console.log to print debug messages to the console. This is a very simple technique. All you do is use console.log some message, and when you run the code, the message will be printed on the console. Simple and straightforward. But what you may not know is there are other methods available under console that you can use to classify different levels of your error message. For example, I can use console.error to print out an error message. So similarly, there is console.info info message, and debug message, and there is one more console.one. And when you print out these error messages, you can see the messages are being styled differently based on the message level. You can use this level filter to turn on or off certain levels of error messages. For example, if I do not want to see info messages, I can turn them off. And if I turn off warning messages, only the error messages will be displayed. And you can obviously get back to the default level. Apart from this filtration, the other benefit with the console.log messages is you can use this filter text box to filter for some substring. For example, I want to see only the messages that's got text in it. Okay, and as you type, it will start filtering those error messages. And if you leave the search string on, and whenever the new messages are being displayed, the new messages will be filtered based on whatever the search criteria that we had given. So this will be really useful if you are working with a code base that is printing tens and thousands of error messages on the code, and you want to focus on one particular error messages. Like, you can definitely use this search query. The other method that I use heavily is console.time and time end. Console.time end. So the console.time and console.time end is very useful when you're actually working with performance optimization. So basically what they do is, like, you can start the performance measurement with the call console.time, and you can give a label, a test label or something above. And when you say console.time end, you can pass the same label. And when you run it, let me clear the search again. Yes. So now you can see the browser will print the label that you had given and the time taken between the time and calls. So this will be helpful if you're actually profiling some certain part of code and you just quickly want to see how much time it is taking to run. So definitely make use of these methods. The next technique that I want to talk about is using debugger statement. When you use console.log, you are not actually passing the program execution. But if you want to stop the program execution at runtime and want to inspect the variables, then obviously you have to use some kind of breakpoints. One way to introduce a breakpoint in the code is using the debugger statement. For example, let's say we have this simple function that is supposed to be printing out hello world, but when you run it just prints a world and you want to inspect why. So you can add a breakpoint in your code using a debugger statement. Okay. And when you run the code, you can see the program stops at the debugger line. And from here, you can examine the values of all the local variables and all the variables that is available in this context. For example, if I hover over the foo variable, it is initialized to an empty string. So that is why we are getting just the word in the console. And obviously, like you can initialize foo with hello and you can restart the program execution. The other tip is you can directly modify any variable value right in the console itself. For example, I want to initialize foo with hello, okay, and when you run, now if you resume the program execution, you should see the hello world say printed. So this is because we modified the value of foo at runtime. So this will be definitely helpful if you want to quickly modify a particular value and you want to examine what is the program flow after the modification. The next technique I want to talk about is using breakpoints. In the previous section, I talked about console.log and debugger statements. Even though these techniques are very simple, the drawback is that you need to modify your source code in order to have some debug messages. This may be fine in some cases, but you don't want your debug messages ending up in production code. To avoid that, you can definitely use breakpoints. For example, here I have a very simple function called playground that loops through 0 to 10 and calculates if a particular number is even or not. What if I want to investigate what's going on inside the for loop? To do that, I need to set a breakpoint. For example, I want to set a breakpoint at line number 6. I just go there and click on the line number 6 to enable a breakpoint. You can see as soon as I set a breakpoint over here, my breakpoint is displayed under the breakpoint section with the line number where exactly the breakpoint is set. Now, let's start the function. Now you see the program is actually halted at the breakpoint, and when the program is actually halted at a particular breakpoint, on the right hand side you can see all the available variable values are actually displayed, and the call stack is also displayed. This is a very simple program, so it just have 2 entries in the call stack, but in the actual production code you would see the call stack has hundreds of entries. So now if I resume the program execution, it will be stopped again and again till the for loop completes. I just don't want to do it at the moment, so I just gonna deactivate the breakpoint temporarily and then resume the execution. Okay. Now, what if I don't want to stop the program execution at all times? Like I want my breakpoint to be stopped only when certain conditions are met. To do that, just right click on a particular breakpoint and click on edit breakpoint. And now you will get an option for defining the conditions. There is the option called the conditional breakpoint that will pass only when the condition is true. For example, I want to stop this program execution only when the value of is even is true. Now, when I start the program execution, you will see the program stops whenever the value of is even is true. The first time when I equal to 0, obviously the I modulus 2 is 0 is actually true, so it stops. And when I resume the program execution, you can see it stops at I equal to 2. It already skipped I equal to 1 because then I is not even. So now when you resume the program execution again, it's gonna stop at only when the is even value is true. So this is useful when when your production code has like thousands of breakpoints and it's getting called in multiple places, and you want to stop the breakpoint only when a particular value is actually true. Okay, let's resume the program execution. Now, what if you don't want to stop the program execution, but you just want to see a value of a particular value at runtime without stopping the program execution? You can definitely do that using log point. For example, here instead of stopping the program execution, I just want to print the value of is even, and I'm just enabling the breakpoint over here and right click and edit point and change conditional breakpoint to log point. Here you can give any message. For example, I want to say the value of is even is, and you can reference any value that is available at this particular context is even. Okay, now when you run this code, see, so instead of stopping the program execution, it just print the value of whatever the value that we had given to the console. So this is actually using the console.log, but it is actually completely separating the console.log from the source code. You can definitely use this in your breakpoints. Previously, we talked about debugging techniques that needed you to know where exactly to place the breakpoints. But what if you don't know where to place the breakpoints? Let's say in your code base, somewhere there is an error being thrown and you don't exactly know where it is. Let's see how to debug such error conditions in this section. So for the demo, I have a simple playground function that will call another function that will actually throw a test error for us. Let's define that function throw up, throw new error test. Okay. So in your code base, the line that is actually causing the error could be anywhere. Since this is a demo, I'm just placing it in a test function. And let's run the function. Okay. Now you see the error message is actually being displayed on the console. This is the default behavior if the error is not being handled. So one way to find out which line it's actually causing the error, you can directly click on the line number that is printed on the console. That will take you to the line that is actually throwing the error. The other way is you can also enable pass on uncaught exception under the breakpoint section. Okay, so when you enable this pass on uncaught exception and when you run the code, let's clear the console. See, the browser will stop at the line that is actually throwing or causing the error. And once it is actually stopped, you can actually continue with your debugging, or you can even enable the breakpoints in the function that is actually throwing the error. Like you can do whatever the debugging that you want. Now, if I resume the program function, it will actually obviously print the error on the console since the default behavior. Okay. Let me add a try-catch block around the function that causes the error. Okay, catch. Okay, so I just don't know. I'm just not going to do anything just for the demo. Okay, the scenarios, let's say like you have some error handling wrapped around your error throwing function, and if you run the function, okay, you will see like nothing is actually printed on the console, and the program also not stopping at the error causing function. Okay, so how will you deal with this kind of error? So for this, we have another option called pass on caught exception. Okay, so now after enabling this pass on caught exception, let me run the program. See, now the program, now the browser will stop at the line that is actually causing the error. Like even though it is actually being handled, it will still stop the program execution. So after this, you can continue with your normal debugging process. Okay. In the final section, I want to talk about two additional debugging techniques that I often use. One is the DOM breakpoints and the other one is the fetch breakpoints. Let's talk about the DOM breakpoints first. Let's say you're using some third-party library that is heavily modifying the DOM structure of your application. And you want to know where exactly this DOM modification is actually happening, so you can do some debugging around it. For this, I have some test application over here. I have a playground function. Let's say like I want to add a class to a body tag. So I'm selecting the class element, add test. Okay. So this is a very simple code that just adds a class to the body tag. And when I run the code, obviously like if I go to the elements section, and you can see the test class is being added to the body tag. Now I want to stop at the line that is actually causing this modification. So to do that, I need to go to the elements panel and click on the body tag, right click on the body tag and select break on attribute modification. So I'm selecting attribute modification because I'm adding a class to the body tag. You can also use the other subtree modification wherein you want to debug an element being added as a child to the body tag, or a node removal where the body tag itself being removed. But in the current scenario, I want to use the attribute modification breakpoint. I select attribute modification. Okay, and when I come here to the sources tab and under breakpoints, Now you can see the breakpoint that I actually set is actually displayed here. So it will also display other DOM breakpoints as well that is present in your source code. Okay, now let's try to add a new class, test again. Okay, now when I run the code, see, even before it is adding the class name, it will actually stop at the code that is trying to modify the particular DOM element. So here you can do whatever the debugging that you want. Let's run it, and if I go there, now you see test and test again being added. Now let's talk about the XHR or fetch breakpoints. Let's say somewhere in your code there is a network call that is being made, and you want to find out where exactly that is being made. To do that, you can make use of this fetch breakpoints section. Let's say I have a test code that is pinging this JSON placeholder website and just printing the response as a JSON. And I want to figure out where exactly this code is actually being called. For this, I go to the fetch breakpoints section and I click on a new breakpoint. And I want to break when a URL contains this fragment JSON placeholder. Okay. So now that I have set a breakpoint, and whenever I run this function, whenever a call is being made with a URL that contains this JSON placeholder, the browser will halt the execution and will put the line that is actually firing the network call. So from here, you can continue with your usual debugging method. With that, we come to the end of this session. Thanks for watching the video, and do let me know if you have any comments. Please subscribe and share the video if you found it useful. See you soon in another video.